Air is mainly made up from two gases, oxygen and nitrogen. 21% of the air is oxygen and 79% of the air is nitrogen. The pressure of air at sea level is 1 bar. So 21% of that pressure comes from oxygen and 79% of it comes from nitrogen. We call the pressure exerted by each gas the partial pressure, because it is part of the total pressure. In air with 1 bar of pressure, the partial pressure of oxygen is 0.21 bar, and the partial pressure of nitrogen is 0.79 bar, and together they add up to 1 bar. When you go down on the water, the total pressure gets higher, and this means that the partial pressures of each gas also gets higher. For example, if you go down to 10 meters of seawater, the total pressure of air you are breathing goes up to 2 bar, double of what it was at the surface. This means that the partial pressure of oxygen and nitrogen will also be double of what it was at the surface. To find out what the new partial pressure of each gas will be, multiply the surface partial pressure by the total pressure at the depth you are. So, at 10 meters, at 2 bar, the partial pressure of oxygen is 0.21 multiplied by 2, and this equals 0.42. And the partial pressure of nitrogen is 0.79 multiplied by 2, which equals 1.58 bars of pressure. If you add them together, 0.42 and 1.58, you get 2 bars, and that's the total pressure. Another example, at 30 meters we have 4 bar, and the partial pressure of oxygen is 0.21 multiplied by 4, and that equals 0.84. The partial pressure of nitrogen is 0.79 multiplied by 4, which equals 3.16 bar. If we add them together, 0.84 plus 3.16 equals a total pressure of 4 bar. Note that the percentage of the gases in your tank does not change. Oxygen is still 21% and nitrogen is still 79%. But the pressure each gas exerts goes up because the total pressure goes up.
This is important because some gases become very dangerous when they reach a certain partial pressure, and this includes oxygen. Oxygen can become toxic to humans when it reaches a partial pressure of 1.4 bar. When breathing normal air, we reach this partial pressure at a depth of 56 meters, where the pressure is 6.6 bar. 0.21 multiplied by 6.6 equals 1.4 bar partial pressure of oxygen. Let's see what the partial pressure of oxygen is in normal air at the recreational diving limit of 40 meters, where the pressure is 5 bar. 0.21 partial pressure of oxygen multiplied by 5 bar equals 1.05 bar. So, breathing normal air within recreational limits is very safe. However, when breathing enriched air nitrox, it is possible to have problems with oxygen when diving within recreational limits. It is nitrogen that limits our dive time. This is why we make enriched air nitrox. We make nitrox with more oxygen in the blend so that we can put in less nitrogen and extend our dive time. For example, we might use a blend of nitrox with 34% oxygen and 66% nitrogen. In this blend, the partial pressure of oxygen is 0.34 bar and the partial pressure of nitrogen is 0.66 bar. If we dive with this blend of enriched air nitrox to a depth of 25 meters, where the pressure is 3.5 bar, the partial pressure of the oxygen will be 0.34 bar partial pressure of oxygen at the surface multiplied by 3.5 bar, the pressure at 25 meters, which equals 1.19 bar. This is safe. However, if we dive with this blend to 32 meters, where the pressure is 4.2 bar, the partial pressure of oxygen will now be 0.34 bar multiplied by 4.2. And this equals 1.42 bar. This is now higher than the safe limit. This is why special training is needed to use enriched air nitrox. The other gas that can be a concern is carbon monoxide. We will talk more about the effects of carbon monoxide poisoning in the physiology of diving. But here, let's see why even a small amount in your tank can be very harmful. Let's say that 0.5% of the air you are breathing is carbon monoxide. That means that the partial pressure of the carbon monoxide is 0.05 bar. Now, at the surface, that probably wouldn't be a problem. But let's see what happens at 30 meters of seawater. The pressure at 30 meters of seawater is 4 bar. So the partial pressure of the carbon monoxide will be 4 times higher. 0.05 bar multiplied by 4 equals 0.2 bar. With every breath you take in 4 times as much carbon monoxide as you would do at the surface. So now the air you are breathing has the equivalent effect of breathing air with 2% carbon monoxide, because the partial pressure is now 0.2 bar. This is called equivalent percentages. At 4 bar of pressure, 0.5% of carbon monoxide will have the same effect on your body as 2% would do at the surface. The actual percentage is still the same. but the effect is higher because the partial pressure is higher. Remember, if you want to practice more examples of working out partial pressure, download the worksheet from the resources for this lecture.